Hello and welcome. This is AnomaNet demo video. It runs 5 ML models over them and surfaces suspicious behaviors as ranked alert on a live dashboard. I am going to show you the complete data flow from synthetic data generation through Kafka, through the ML scoring engine into the database, and finally onto the UI. Everything working on real code. The pipeline starts here from the simulator.py file. Since we are not connected to a live bank, the simulator generates realistic Indian banking data, customers, accounts, and 1 lakh transactions spanning 90 days. Channel weight match real UPI, NEFT, RTGS uses, KYC tiers, income ranges, occupation, all modeled after Indian bank profiles. It injects 5 real fraud typologies: layering, circular transaction, structuring or smurfing, dormant account activation, and profile mismatch. Each generate around 1,000 level fraud transaction mixed into clean data. These are the same pattern regulator look for. Let me run it now in VS Code terminal. See the breakdown: structuring, layering, circular, dormant, profile mismatch, all labeled. The output is 6 barcode files: transactions, accounts, customers, tables, and graph node and edges. File ready for new forces. This is the ground truth the entire pipeline is built on. The runtime pipeline is Kafka driven. There are 3 topics. Raw transaction is where transaction events land first. The Spring Boot backend consume it, save the transaction to Postgres, write the graph edge to Neo4j, then publish an enriched event to ml.scoring.queue. The ML service picks that up, score it, and if the score crosses the threshold, publish to alert.generated. The backend then saves the alert to Postgres and pushes it to the frontend via WebSocket. So, there are 2 databases in the system. Postgres holds structured record transactions, alerts, cases, users. Neo4j holds the transaction graph, account nodes, edge label transferred to, and a live Anoma score property on each account that gets updated in real time as scoring run. Every transaction that comes in gets scored by 5 detectors simultaneously. The formula is right here. Isolation forest for layering weighted at 0.25, circular detector at 0.3, XGBoot for structuring at 0.2, logistic classifier for dominancy at 0.1, and autoencoder for profile mismatch at 0.15. These weights are configurable at runtime through the admin panel. You don't need to redeploy it. The ML consumers also queries Neo4j before scoring. It computes residency time, which is how fast money moves through an account, and fetches the last 7 days of transaction for structuring detection. So the graph is not just for display, it's an active input to scoring engine. The backend is a Spring Boot monolith. You can see the packet boundaries here: alert, cases, graph, auth, transaction, simulator. Each was designed as a microservice boundary but consolidated into one deployable. Spring Data JPA connects to Postgres. Spring Data Neo4j connects to the graph. Fly away, run the database migration. JWT handles auth. Now coming to the dashboard. This is the front end, which is built on Next.js app, which is connected to the backend via REST and WebSocket. The alert panel shows every flag transaction ran by Anomaly code. Each card shows the account, the typology detected, the score, and the timestamp. Each alert has an explainability output, plain English explaining why the account was flag generated by the autoencoder-based explainability module in the ML service. Now the graph view. This is the Neo4j data entered in the browser. Every node is an account or a customer. Every edge is a transaction fraud. Clusters visually stand out. Rings for circular transaction, stands out for layering. An analyst can escalate directly from here to case watch. To prove the full pipeline is working end to end, I will trigger a new fraud scenario live right now. This hits the Spring Boot simulator endpoint, which calls the ML service, which generates a fresh layering cluster in memory, publishes it to raw.transaction, and the whole Kafka pipeline runs. Transaction shaped to Postgres, edge written to Neo4j, code alert published, WebSocket pushes to the frontend. And there it is. In the terminal, I type the command and wait for a few seconds, and we got a new high score layering alert appearing in real time with no page refresh. That's the WebSocket connection working. Now clicking on the new alert on our dashboard, and we can see the score breakdown and typology level. So this is the complete input-output data flow. The data simulator produces synthetic transaction with labeled raw typologies. At runtime, transaction enter via Kafka's raw transaction topic. The backend saves them to the Postgres and write graph edge to Neo4j. The ML service score each one using 5 model with a composite anomaly score. If the score crosses 0.65, an alert is published to Kafka, saved to Postgres, and pushed to the frontend in real time via WebSocket. Analysts review alert, explode the graph